Hey, what's up, guys? I am sorry that I cannot make it into class today. I have a family emergency, so what I'm going to do is go ahead and give you the version that I would do in real life, but it would be a video. So you do not have to come to class today, um, but it's going to go through and complete module number 9. So this might go a little long, but it's excellent and super easy to do. So the first thing I want to talk about is standard deviation. So, what is standard deviation? Standard deviation is the measure of a variation based on measuring how far, on average, each data value deviates or is different from the mean. So, how far away is it from the average, if that makes sense? Okay. Um, Few important characteristics is the standard deviation is always positive or it could be zero, and that's okay. You're never going to get a negative standard deviation. Standard deviation will be zero if all the data values are the exact same and will get larger as the data spreads out. Okay. Standard deviation has the same units as the original data, and standard deviation, like the average, can be influenced by the outliers. Now, range range only uses range only uses two values. So range only uses two values from the data set, the high and the low. However, standard deviation uses everyday data or uses every data value to determine how the spread of the data is. So you can think of standard deviation as roughly meaning the average distance from each data value from the mean. So how far it is from the average. So it's dictated by the average. I don't know why it keeps cap locks in it there. So there's lots of easy ways to do this. So each of these data sets have the same mean and range. So if I do this real quick, I do 1 plus 1 plus 1 plus 5 plus 9 plus 9 plus 9, and I divide that by 1, 2, 3, 4, 5, 6, 7. I add that up, I get an average of 5, and then the highest from my lowest is 8, right? And that's the same thing with this one, all right? This is no big deal. So just know that when you look at this, you got 1115999 and 1555559. So which, at a glance, which data set appears to have a greater spread? Like how far out are they? Well, even though they have the same range in the mean, you could say that data set A has a greater standard deviation, I guess. Right? So I'm going to show you a super easy way to compute um, standard deviation. Now, there's a couple things. I got standard deviation and variance, and I do not want any of you to ever do any of this. So let me show you how easy it is. So variance is a squared formula, and variance is just you don't really need. If you need to find the variance and connect math, I'll show you how to do it using our friend Desmos. So check this out. I'm going to open up Desmos real quick. I'm going to go to graphing calculator. All right. Now, I can type in any list, any set. So if you look at my stuff right here, like I got 111599999, right? See that? 1115999. I'm going to type that in. I'm going to go A equals, I'm going to do a bracket, 1115999. And close my bracket. Now, what's cool about this is you can find everything. Watch this. I can go down here and I can go into functions and I can open up statistics and I can find the mean. And I just type in A and the average is 5, right? So that's good. And then if we want the standard deviation, I can go to functions and I can go right here to standard deviation. You want to pick this one, the STDEVP. That's the whole sample versus a population. If you take statistics, we'll talk about that, but you're not. So standard deviation of A. Boom, the standard deviation is 4. Now, if you take the standard deviation, if you take the variance, there's one more thing I forgot before you go to variance. This is the standard deviation of an entire sample, but if you have to find the standard deviation of a population, you're going to go right here to standard deviation of the population. Boom, and you type in A. Whoops, not SA. A. So you get 3.7. The variance, you can just click on that, but you're never really ever going to have to find the variance because most likely they're going to ask you, but you can type in variance. You know what? You can type in variance. I think if you, I'm pretty sure that's what that one does. You do variance of A, it will give you 16. And they only do the variance of the sample population or sample standard deviation, not the population. Another shortcut is you can go to functions, and I think if you go to stats, well, let me close this out. If you go to stats, I think it will spit everything out right for you. So you don't even have to do all that work. Yeah, if you go to stats, well, this is something that we'll talk about in a minute, but it gives you your quartile 1, your quartile 3, your median, and your max and your min to help you with box plots, which we're going to get to in a minute. So we'll talk about that in a second. So there's your standard deviation. So for the first set I did, for A, our population standard deviation is 3.7. Let's go ahead and do that other one, which was B. So we'll call it B. In a bracket. And if I look back at that problem, what was B? 155555559. Do 1 comma 5. Whoops, missed it. 1 comma 5 5 5 5 5 9. All right. Now I'm going to find I'm going to click here. I'm going to go to functions. I'm going to go to stat. I'm going to find the mean. I'm going to type in B, and you see that the mean is 5, right? But then I can actually type in STDEVP for the population of B. So you can click on it or you can do it automatically. And you see 2.13. So this population standard deviation is 3.7. This one is 2.13. Question might be, why are we doing population and not sample? Because the population is those are all the numbers we have. Now, if we had a sample, it will say take the standard deviation. All right. So that's how you do that. Let's take a look at another example. So cruising on down there, we have that. So which of the following data sets would likely have a higher standard deviation and why? Hours per week spent on homework by a full-time graduate student in a particular program versus hours per week spent on homework by a high school student. What do you think would have a higher standard deviation? I'm probably thinking that B, the hours per, B would vary more widely because how many high school students even do their homework? All right. So that's how you find that. Now, when we're talking about measures of position, we're going to talk about percentiles. People talk about, oh, my baby is in the 98th percentile for weight. That means you have the fattest baby around or the biggest head. The best percentile to be in is the 50th percentile. Right? People always worry about percentiles when they're younger, but when you deal with testing, if you're in the 50th percentile, you're all right. So percentiles are used in statistics to indicate a value which is a value below. Percentiles are used in statistics to indicate a value below which a certain percentile of data fall. For example, if you score in the 60th percentile on a standardized test, it means you're 60% higher than everybody else. All right, so 40% of the people that took the test were better than you. That's not bad. That's actually really good. So a percentile or percentile rank of a value indicates the percent of data values in a set that are below a particular value. And this is how you figure out the percentile rank is number of data is below divided by the total number of things times 100. So let's do this. So what percentage of the value in a data set lie at below the 30th percentile? Well, that's easy. That's 30%. What percent of values lie at above the 30th percentile? Well, think of 30 plus 70 makes 100, so 70th, all right? Or 70%. Now, if 500 measurements were taken, approximately how many would be at or below the 30th percentile? All you do here is you take 30% of 500 and you get, I think you get 150. So 150 measurements would be below the 30th percentile. To get above, you can take the complement or you can go 0.7 times 500. And then I think you get 350 with that. Okay. Not too tough. Let's look at this guy right here. Percentile. Suppose you score 71 on a test with 10 other people with all 11 scores listed below. What is your percentile rank? All right. So what we got? So the first thing you got to do is you got to put this in sequential order. So what's the lowest test? I guess that's 52. And then we got 52, and then who's next? Was that 64? 64, 71, which I think is you, right? You got the 71, and there's 75, 77, 82, 88, 90, 93, 93 and 98, 93, 93, and 98. So I put them in there, and then you got 71. So this was you right here. So this is you right here, 71. So how many people, you got 2 scores below you? So I'm going to do this. I'm going to take 2, and I'm going to divide it by 11 because there was 11 data points. And when I do that, I get 0.181, meaning 18th percentile, right? So it'll be the 18th percentile. Let's try another one. So consider the height in inches of a sample of 8 females. So these are the heights in inches. Find the height that roughly corresponds to the 38th percentile. First thing you want to do is you want to put this in order from lowest to highest. So let's put this in order from lowest to highest. So 59 inches, 60, 62, 64, 66, 60, oh, 60, 62, 64, 66. I keep moving this up. 66, 67, 69, and 70. So there we have that. Now, how many people were there? There's 8. So what we got to do is we got to take the 38th percentile. So we're going to do 8, because there's 8 of them, times the 38th percentile. When I do that, I get 3. So 1, let's see, there's 1, 2, 3. There are 3 scores below 64. So 64 would be the one in the 38th percentile because that's where it ends up. All right? Seems pretty simple. Let's close out with mean, quartile 1, quartile 2, box plots, and all that good stuff. Okay, let's close out with that. So when we talk about the 5-number summary, those are easy. It's your 5-number summary is the first one. We call it the second quartile, which is the median, which you add them all up and it's the middle one. Quartile 2, which is the median of the lower half of your data. Quartile 3, which is the median of the upper half. All right. And we don't have to worry too much about any of the things that like find how to calculate it. It's real easy. Check this out. Here is, it says find Q1, Q2, Q3 for this data set. So you got 3, 4, 5, 5, 8, 9, 9, 9, and 10. I can take this information. I wonder if I can take this information and I'm going to copy it. I'm going to open up Desmos and I'm going to paste it. So I'm going to put a comma there. 3, comma, 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 comma. All right. And I'm going to label this A. Actually, I should probably put this in a bracket. I'm going to label this A. This is the easiest peasiest thing you ever seen. Capital A. Enter. Now, I'm going to go to functions. Click this box. I'm going to go to functions. I'm going to go down to statistics. Stats of A. And it spits out my minimum, which is 1. My quartile 1. Oh, wait. That's not what I want to do. Hold on. Let me back it up. That's the wrong A because it didn't do it. Let me do it this way. A equals, and we'll go 3, A equals 3, 4, 5, 5, 8, 9, 9, and 10. There we go. Now I'll go stats, functions, stat, and we'll go A. Sorry, I goofed up there. I'm going to change it to C. And I just go to stats and I go to C, and now I have it. Quartile 1 is 4.5. My median, which is quartile 2, is 6.5. Quartile 3 is 9. My min is 3. And my max is 10. All right, that's as easy as it is. Now, if you got to make a box and whisker plot, all you got to do is type box plot, parentheses, and I named it C. And there's my box plot right there. See, look. This is my minimum. This is my maximum. Here's my quartile 1, 4.5. Here's quartile 2, median, 6.5. And here's quartile 3, 9. There's your box and whisker plot. All done for you. Super easy. Don't have to worry about any mathematical stuff. So I guess that's a good way to end it because the next module we're going to be doing is going to be dealing with other types of stuff. So Desmos is your best bud through all this. I do not want anyone thinking of trying to figure out how to do this by hand because there's no need to. Because if you take statistics next year or next semester or whenever, you can use a graphing calculator. So I again apologize that I'm not there today. Again, I had a family emergency, so giving you 20 minutes of live instruction via video. How about that? So I'll see you all next week on Monday. Have a great day.